everybody. There we go. All right, so we're going to do one more example. I promise this is not a 20-minute video like the last one. There's no timer as I record these, and I probably should put one on my phone so I know how long I've been recording. But yeah, sorry about the 20 minutes last time. That was, just me going a little bit crazy. But anyways, shorter, I promise. So we're in example 4 now. The Taylor series about x equals 0 for a certain function converges to f on the interval of, okay, the nth derivative is given by a fraction the likes of which I have not seen. Well, I've seen this question before, but still. This giant looking thing for n is greater than or equal to 2, so I use that for the second derivative a lot. Fine. The graph has a horizontal tangent at 0, and f of 0 is 6. Okay, so let's first talk about what should you be getting from the root of the problem. First, Taylor series about x equals 0, so that means this is a Maclaurin. Taylor converges to f, the nth derivative. Okay, so this is going to help me get my numerator. So this is my numerator for my x squared and up terms. And then they tell me this, f has a horizontal tangent line at x equals 0. Well, a horizontal tangent line would look like this, and I'd only have a line that looks like that if the slope is 0. So that means I know that f of 0 is 6, and I know f prime of 0 is 0. That's why they can give me this derivative equation starting at 2, because the 0th derivative, quote unquote, is just your y value, and the first derivative is your slope, and they told me about that in a different way. So A says determine whether f has a relative max, relative min, or neither at x equals 0. Okay, well, then you have to think back to what did you know before? I know that f has a relative max, min, or neither if the derivative equals 0 or is undefined. And then I can look at the second derivative to see if it's concave up or concave down. Because if my derivative equals 0 and my second derivative is negative, I've got a max. And if the derivative of 0 and the second derivative is positive, I have a min. So yeah, what I would do here is say, using the second derivative test, f prime of 0 equals 0, and f double prime of 0 is, well, now I'm going to look up here. I want the second derivative, so I'm going to plug in 2. Negative 1 to the third, 3 factorial, 5 to the second, and 1 to the second. Well, if I look at that, I don't even really care what the value is. All I care is that it's going to be negative. So f double prime of 0 is a negative value. Therefore, f has a local max. And that would get you full credit because you've shown that you've identified a derivative that equals 0. You've identified the sign of the second derivative. You've said, I'm using the second derivative test, and I know what that means. And so I'm going to assume you know what that means. And since your second derivative is negative, it has a local max. You'd be free to write more and just say, hey, it's got a local max because it's got a horizontal tangent line and is concave down. That's okay too. All right, let me erase some of the nonsense I've got up here. So then it says on part B, write the third degree Taylor for f about x equals 0. Okay, so if I want the third degree Taylor for f, I need to get all my numerators. So I'm going to make my list like I used to here. So I know f of 0 is 6. Come on, computer. There we go. F of 0 is 6. I know f prime of 0 is 0. I know f double prime of 0 is, now let me simplify this here. It's going to be negative 3 factorial over 25. And then I know f triple prime of 0 is going to come from n equals 3 up here. So when n equals 3, I'm going to have negative 1 to the fourth. I'm going to have 4 factorial. I'm going to have 5 cubed and 2 squared. And so that's going to be, let's see, a positive 4 factorial on top. And on the bottom, I have 125 times 4. And 125 times 4 is what? 500? Can I math today? I think that's 500. We're going to go with that. All right. So now these are all my numerators. So when I make a Taylor series, I have 6 over 0 factorial x to the 0, 0 over 1 factorial x to the first, and it's just x because we're centered at x equals 0. And then I have, now this whole thing needs to become my numerator. So I'm going to leave it in this unsimplified form, and you're going to see why in a second. So negative 3 factorial over 25 over 2 factorial x squared, and then 4 factorial over 500 divided by 3 factorial x cubed. Now we're going to have fun simplifying factorials. 3 factorial is 3 times 2 times 1. 2 factorial is 2 times 1. So what happens here is these cancel and just leave a 3 behind. Same thing over here. 4 factorial, 3 factorial is 4, 3, 2, 1. And if I could write well, 3, 2, 1. So these cancel, just leaving a 4. So if I simplify this more, 6 over 0 factorial x to the 0 is just 6. That turns into 0. This becomes 3/25ths. And this becomes 4/500ths. And you do not need to simplify. So it says write the third degree Taylor polynomial. Yeah, I did that. There's the third degree Taylor polynomial. And then C says write the general term for the Taylor series about f of x for x equals 0. So the general term is the nth derivative at 0 over n factorial x to the n. Well, fortunately for us, I have an equation for the nth derivative. It was way up top here. It's this monster. So if I want to write the general term, I'm going to copy that down. There's the nth derivative divided by n factorial times x to the n. And I can go one step further and say, you know what? N plus 1 factorial divided by n factorial really just becomes n plus 1. Kind of like 4 factorial over 3 factorial just became 4. Same thing here. So my general term is negative 1 to the n plus 1 times n plus 1 divided by 5 to the n minus 1 squared x to the n. Short video. That was 8 minutes. Sorry it was, more than 5, but it was less than 10. So I have nothing else for you today other than the fact that we've been playing with synonyms lately. And so my kids came up for a synonym for wind turbine, and wind turbines in my house will now be called energy fans. So I thought that was appropriate and a little bit funny. The other one we came up with that I have to credit my husband with is we could also call a wheelbarrow a dump tricycle. So there's your 2 jokes for today. What's another word for a wheelbarrow? A dump tricycle. See you later. Well, no, I won't see you later. Maybe we will next week.